longest journey begins with the first short step. During 1964, this nation took significant strides in space exploration through the achievements of the National Aeronautics and Space Administration. At Cape Kennedy, Florida, an impressive series of space launches helped pave the way to our initial goal, the moon, and to the planets beyond. During the early morning hours of January 29th, America's mightiest rocket, the Saturn I, stood majestically silent on its launch pad. This dawn was to mark many space firsts. This, the fifth of the Saturn I test series, was to be the first launch from Complex 37. The first use of stabilizing fins on the rocket. The first time all 8 engines would be operated at full power. And most important, it was the first flight of a live second stage in the Saturn vehicle. Preparations for the launch were begun. Then the countdown, extending over 2 days. The final 2½ minutes of the countdown were directed automatically by a computer. At T-minus 3 seconds, ignition. The engines reached full power, 1½ million pounds of thrust, and the hold-down arms released the rocket. After 2½ minutes of flight, the Saturn was 48 miles up, moving at 5,000 miles per hour. As scheduled, the first stage engine shut down. The first and second stages separated. The 6 engines of the second stage were ignited, and the world's heaviest satellite, 19 tons, was placed into orbit. Later in the year, Saturn undertook a different kind of mission, the testing of the Apollo spacecraft. Apollo is NASA's 3-man lunar landing project. If all goes well, this complex spacecraft will carry American astronauts to the moon within this decade. The first Apollo spacecraft, called a boilerplate, was carried aloft by the Saturn in May. Was to test the design of the spacecraft model during flight. The launch escape system, designed to pull astronauts away from the rocket in case of trouble, also was to be tested. Late in May, the first Apollo spacecraft to fly was carried into space. These spectacular scenes were recorded by cameras attached to the Saturn during flight. On signal, 8 panels, such as this one, were blown out. Next, small rockets were fired. This gave the second stage a slight forward thrust and pushed its hydrogen fuel into proper position for smooth ignition. Second stage engines ignited, and the 37,000-pound Apollo payload sped into orbit. Another Saturn was launched on September 18th, completing the Saturn I Apollo program for 1964. The bridge between Apollo, the moon landing program, and Project Mercury, our first manned venture in space, is a program called Gemini. The Gemini spacecraft will carry 2 American astronauts into space. Gemini will test man's ability to perform efficiently during long periods of weightlessness. And it will develop the technique of meeting and joining 2 spacecraft in orbit. This technique is an essential step in the moon project. The first Gemini spacecraft, unmanned, was successfully placed into orbit in April by a Titan II rocket. The second Gemini launch was set for December 9th. It arrived at Cape Kennedy in September and was checked out at the new NASA launch area on nearby Merritt Island. On launch day, the Titan II's engines roared into life at ignition. But the engines were stopped before liftoff by a safety device. This device reacted when instruments indicated an engine had jammed into an abnormal position. Despite the delay in the second Gemini launch, astronauts for the first manned flight continued training at Cape Kennedy's Mission Control Center. This is a Gemini simulator, equipped with an instrument panel like that of a flyable Gemini spacecraft. It is used to train astronauts in controlling the craft. Any one of 600 spaceflight problems can be programmed into the simulator by computers. If an astronaut crew handles everything too smoothly, a number of problems can be unleashed simultaneously.
Electrical power STC, report main bus voltage and current. This is electrical power, main current 20 amperes, main volts 27.5 volts. Electrical power, spacecraft internal power on.
After many hours in the simulator, the Gemini astronauts will be ready for their first flight in 1965. Although emphasis remained on manned spaceflight, NASA forged ahead in a vigorous program of unmanned exploration of space. To carry out this program, 3 types of rockets were launched at Cape Kennedy by the Goddard Space Flight Center's launch operation. These were Centaur, Delta, and Atlas Agena. Centaur is being developed by NASA's Lewis Research Center. It is being groomed to place on the moon, intact, an instrumented spacecraft named Surveyor. Surveyor will precede men to the moon to give astronauts information on the makeup of the lunar surface. The Centaur combines an Atlas first stage and a liquid hydrogen second stage. Centaur number 3 was launched in June, but was considered only a partial success because the hydrogen engines cut off prematurely. In December, Centaur 4 was launched. It put a 2,100-pound mock-up of the Surveyor into Earth orbit. The Delta vehicle is NASA's workhorse rocket. A new version of Delta with strap-on solid motors was used to place the Tinkoff 3 communication satellite into orbit. Tinkoff 3 was maneuvered into a precise circular orbit high over the Pacific Ocean. Since Tinkoff 3's speed matched the Earth's rotation, it appeared to stay in a fixed position. Thus, the satellite achieved the world's first stationary orbit. Another communication satellite, Relay 2, was launched on January 21st, 1964. It was placed into orbit over the Atlantic, where it transmitted television and radio messages between North America and Europe, forging another communications link between the old world and the new. Later in the year, the Atlas Agena rocket was used to launch the Mars Mariner deep space probes. Mars Mariner, built by Jet Propulsion Laboratory, is designed to give man his first close-up look at the planet Mars. The first of two back-to-back Mars Mariners was launched early in November, but it failed when a covering of the spacecraft did not separate properly. On November 28th, the second spacecraft, Mariner 4, was successfully launched on its long 7-month voyage to Mars. Several days later, a mid-course maneuver put Mariner on a path which will bring it within 5,000 miles of the surface of the red planet. Photographs of Mars and other information will be transmitted from the spacecraft, immeasurably adding to our knowledge of this comparatively nearby neighbor. Other satellites launched during the year included OGO, IMP-B, and Explorer-D. OGO, Orbiting Geophysical Observatory, represents a new concept in spacecraft engineering. OGO is a standardized satellite designed to accommodate a variety of space missions. The first OGO was launched on September 9th with 20 scientific experiments on board. Despite mechanical problems, after the satellite was placed in orbit, 16 of the experiments operated as planned. Another multi-purpose spacecraft is designed for interplanetary studies. It is called IMP, for Interplanetary Monitoring Platform. IMP-B, NASA's second interplanetary explorer, was launched in October. It carried 9 experiments to measure radiation and other hazards which might be encountered in moon flight. Although IMP failed to achieve its planned orbit, it sent back to Earth usable information. A radiation detection satellite called EPED was placed into orbit on December 21st. The 101-pound satellite carried 5 experiments to study the natural and artificial radiation belts surrounding the Earth. In an effort to learn more about high-speed re-entry heating problems, NASA launched Project Fire in April. The Project Fire spacecraft, equipped to take more than 300 measurements of space heat, was a success. The Atlas Agena booster played a key role in another scientific milestone during 1964, the Ranger mission to photograph the moon. To chart possible landing areas for American astronauts, NASA launched Ranger 6 and Ranger 7. Ranger 6 hit the moon, but its cameras failed. Ranger 7, however, was a different story. It astounded the scientific world with its photographs of the lunar surface. The Ranger spacecraft is 15 feet across and 10 feet tall. 2 solar panels provide the electrical power required during flight. Shortly after noon on July 28th, Ranger 7 began its historic journey to the moon. Almost 3 days after launch, 6 television cameras aboard the spacecraft began taking photographs of the lunar surface. These are some of the more than 4,000 high-quality pictures which moved manned exploration of the moon a step closer to reality.